Assalamualaikum and good evening. Okay, alright. So like what I promised, for today class, which is the Thursday class, right? I will show the example on the numerical differentiation. Okay, so and I hope that all of you already fill up the table that I already attached in the ULearn. Okay, dekat bahagian short question tu saya ada attach satu file. Okay, I hope that you can fill up that one first. It's more easy for you if you can gather all the formula, and then by referring to that formula later you can answer all the question lah. Maksudnya tak adalah you sekejap you nak refer back to the slide or to the notes kan. So why not you just fill up that one first. Okay, so now we go to the example 1. Okay, so this example, okay, the question asks you to use forward and backward differential approximation of OH and centered differential approximation of OH square to estimate the first derivative of, okay, given your function at 0.5 using the step size h equal to 0.5 and also h 0.25. Okay, so means that they have two value of h, means that you need to calculate two. Okay, maksudnya ada dua benda lah you nak, satu pada h 0.5 and another one is on h 0.25. Okay, but before that you need to digest first your question. Okay, if you refer to the table that I give you, the table that I ask you to fill out, right? They have two, which is the first derivative and also second derivative. Okay, so means that the first thing first, you need to digest or you need to identify this question asks you to do which derivative first or second. Okay, so clearly that here is the sentence here, first derivative. Means that you need to find all of this forward, backward, centered by using the first derivative formula. So you can ignore the formula of second. Maksudnya you boleh abaikan yang second derivative tu, tak ada kaitan pun dengan soalan ni. Okay, so means that you just refer to the first derivative formula, and for the first derivative formula they have 6 total. Okay, ada 6 formula lah keseluruhan. Okay, which one that you want, that we need to use? Okay, you go back to the question now. Okay, it said here forward and backward of OH. Forward and backward of OH. Okay, so maksud dia apa? So means that forward and backward OH ni adalah untuk normal accuracy. Okay, normal accuracy. So means that you just refer to the normal side, normal accuracy. Okay, and then for the next one is a centered differential approximation of OH square. Centered, okay, tadi forward and backward OH. Okay, forward and backward is OH, and now centered is OH square. So centered OH square means it's normal or high? It's a normal, right? It's still a normal. So means that all of these three must be a normal accuracy. So you just refer to the formula that, okay, first derivative and then forward, backward and centered of normal accuracy. Okay, so means that formula lah yang you kena guna. Okay, I put it aside first, this question, so I write here. So you need to calculate forward. Okay, we do it for h 0.5 first. Okay, we do it for h 0.5. So we do it for forward OH, and then backward OH, and also centered OH square. Okay, all of these are normal accuracy, and this is for first derivative. Okay, so the formula for forward OH apa? Dah tulis belum? Okay, what is the formula for forward OH for normal? For first derivative. F prime x equal to fx plus h minus fx over h. Okay, so this is the formula for forward OH, forward normal. Okay, for the first derivative. So you can see that this is f prime. So means that this is a first derivative. Okay, how about backward? Okay, for the formula for backward is given by f prime x equal to fx minus fx minus h over h. Okay, can you spot the difference here? Kalau sini tadi forward, we start first with fx plus h. But for backward is fx minus h at the back. Okay, means that dia adalah something that different between these two. So hopefully that you can remember, kena tahulah which one is forward, which one is backward. And then for the third one, oh sorry, you tak perlu pun nak hafal actually kan, sebab dia open book. So means that you can refer to the table that I give you, that the table that you fill out just now. Okay, you can bring that one in your final letter. Maksudnya you boleh letaklah kat sebelah untuk easy for you to refer. Okay, alright, for centered. Okay, for centered is f prime as f x plus h minus f x minus h over 2h. Okay, right. Okay, can you see? Okay, this one center is combination. Dia boleh kata combine between forward and also backward tadi. And then over 2h, 2h. Okay, so we already have all this formula. Now we want to substitute what we need to find out here. Okay, kalau you tengok formula for forward, you need to calculate fx plus h and so on. So you already have the value for x and h, right? Okay, back to the question now. Okay, you have the value for x. It given to you your x, and it also give you the h. Okay, so now we do it for h 0.5, is that? So this one you abaikan dulu, ignore this one first. Okay, we do it for x 0.5 with h 0.5. So you just substitute 0.5 plus 0.5 minus f 0.5 over 0.5. Okay, so then simplify lah. So inside here you have f1 minus f 0.5 over 0.5. Okay, so now what's the value for f1 and f 0.5? Okay, what's the value? So to get the value f1, f 0.5, okay, you already done it before in a chapter what we call dalam bisection. Bisection kan you dah pernah calculate. If we substitute value inside your function, you using your calculator, you get the value, right? So the same thing lah, konsepnya sama, tak ada beza pun. What's the mean by f1 here is you just substitute 1 into your equation here. Okay, substitute 1 into this equation, and then you will get the values. After that, you substitute 0.5 into your equation, and then you get the value. Okay, so I will show you. Okay, one here. So for easier for to make it life easier, you just set up first the equation here. Okay, so 0.15 x squared minus 0.5 x plus 1.2. Okay, so you already what we call you already fill up the equation inside your calculator now. So you need to press CALC here. Calculate, not equal. You need to press calculate CALC, and that will come out x, and then question mark. Okay. So substitute the value that we want to substitute here is 1. So you press 1. Okay, and then equal. So you have 0.85. So means that the f1 just now the value that we get is 0.85. You can substitute. Oh, salah. Okay, silap. X cube, So x cube. Okay, I write it back. Okay, I substitute back. So 0.15 x cube. X cube, sorry, tadi saya buat x square. Minus 0.5 x plus 1.2, and then CALC 1. Okay, 0.85 juga. Okay, sebab dia satu, tak effect. Okay, 0.85. And then you do it the same thing. Okay, you just CALC back, and then now substitute the value 0.5. So you have 0.9688. Okay, kalau you buat up to 4 decimal. Okay, I suggest you, okay, if the question doesn't state how many decimal point that you need to calculate, you do it up till 4 decimal point. Okay, make it standardized all 4 decimal. Unless if the question give you the what we call the hint lah, maksudnya dia suruh buat up till berapa, you follow that question lah. Tapi if the question doesn't state how many, so make sure you do it up till 4 decimal point. Okay, and then over 0.5. Okay, so now just calculate lah. Just calculate 0.85 minus 0.9688 over 0.5. So your answer will be negative 0.2376. Okay. 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 Hopefully that you can see lah. You boleh, kalau you tak nampak clear. Okay. I write. Okay, for the backward dengan center saya buat dalam page lain. Okay, so the answer for forward just now is negative 0.2376. Okay, right? Okay, for backward. Okay, for backward Okay, backward. Okay, I hope that you can write lah kat sini backward ke center ke supaya when I'm marking it, I can identify it directly. Saya takut nanti kalau I tak tulis, I tak tahu tu apa, forward ke backward ke center. So now f prime, tadi fx minus h over over h, right? So now your x is 0.5, your x 0.5 minus your h 0.5, and then your h is 0.5. Okay, so f 0.5 minus f0. Okay, 0.5 minus 0.0 over 0.5. Okay, so f 0.5 you already calculated just now. You already calculated, is the answer is 0.9688. Okay, now you calculate for the new one is 0. So CLSC back. So the equation still here. So just CLSC. Alamak. Oh, saya dah ni kita dah divide. Okay, so you need to set up it again. Kena set up balik. Okay, 0.15x cube minus 0.5x plus 1.2, CLC 0. So you have 1.2 and then 0.5. So the answer will be 0.9688 minus 1.2 bahagi, so negative 0.4624. Okay, so this is the answer for backward. Okay, now for centered, fx plus h minus fx minus h divided by 2h. Okay, so actually these two you already calculate, right? You already calculate in the forward and backward. So just substitute it. So this one will be, okay, tak apalah, saya tulis dulu. So this one is 0.5 plus 0.5 minus 0.5 minus 0.5. Okay, minus kat sini. Okay, and then 2 0.5. So this one is f1 minus f0 divided by 1. And 0.5 times 2. 1 And f1 you already calculated just now, will be 1, what we call f1 f1 tadi dah calculate 0.85. And f0 will be 1.2. And then divided by 1. Okay, so you have 0.85 minus 1.2. Negative 0.35. Okay, so yeah, you're done for forward, backward, centered of normal accuracy. Okay, for OH, for the H 0.5. So you can try, okay, by yourself to calculate for H 0.25. Okay, so actually the same thing lah, cuma H dia lah yang berbeza sini. Okay, alright. So this is how we cater the question. Okay, how we tackle the question of the numerical representation. So I repeat it. The first step is you need to identify the question asks you to do it which derivative, first or second. Okay, after you identify that one, you need to know that question asks you to do it on which accuracy, normal or high. Okay, after you get all these two, you can proceed lah with the correct formula. Okay, maksudnya you kena identify dulu betul-betul dia nak soalan tu nak tanya first ke second, accuracy dia normal ke high. Okay, so we settle on that one. Okay, I will give you another one example. Okay, I will give you another one example. Okay, we are still in the first derivative. So for the second derivative, I think you can refer to the slides. You can try figure out how to solve it. Actually it is same lah, cuma berbeza dia kat sini cuma formula, only the formula. Okay, so I give you another one example. Okay, okay, alright. So I repeat. I mention again this question, this example. So the given here table. Okay, it give you a table. Okay, instead of the previous example, it give you equation. Okay, the previous example it give you equation, but now this example give you table. Okay, table. And then the question asks you to use a forward and backward approximation of OH and centered OH square. Okay, so I hope that you already clear on that one. So means there is a normal. All of these are normal. Okay, so sebab center dia OH square. If the center is OH4, then baru dia high accuracy. Okay. To estimate f prime 2.0 using step size. Okay, so my question now, the first thing first, you need to identify this question asks you to do it first or second derivative. Kalau tadi soalan tadi dia mention first derivative, it's mentioned here first derivative, but for this question it doesn't state the word of first derivative. Dia tak tulis pun first derivative. So how we can know that his example want to do first or second? Okay, you need to refer lah to this one. Okay, maksudnya macam ni lah. Saya nak tunjuk dua example yang maksud yang sama, tapi the way how the question write it, maksudnya dalam macam mana cara penyampaian dia. Dia boleh dalam bentuk memang dimension first derivative, or it can give you in term of this term f prime. We know that f prime is first derivative. If f double prime maksudnya second derivative. So make sure you familiar lah dengan jenis-jenis soalan. Jenis-jenis soalan. Dia boleh jadi bentuk tadi, which is dia ada mention first derivative, or in term of this term. But the meaning of that equation sama. Dia not first derivative. Okay, so you already identify it must be in. It asks you to do it for first derivative. So and then the step size already clear here. Okay, what else? Okay, what else? Ada cukup dah. Okay, cukup you dah tahu the first derivative, and then you already know that one is a what we call normal accuracy. Okay, so now forward. Okay, we do it for forward OH first. Okay, even kalau you ingat pun, I suggest you to write back your equation for forward supaya you tak careless lah nanti. Okay, so this is the equation for forward, right? Fx plus h minus fs over h. Okay, so now substitute all the value that we have. So what is your x here? This is your x. This is your x. Okay, instead of tadi, kalau soalan tadi dia bagi dalam bentuk statement x equal to 0.5, sebab dia bagi function. For this one dia bagi macam ni, f prime. So means that this is first order, and then 2.0 inside there. So maksudnya your x is 2.0 lah. Okay, 2.0. And then what is your h? Your h is 0.2 minus fx 2.0 over 0.2. Okay, so now simplify. So you have 2.2, 2.0 and 0.2. Okay, how to get the value of 2.2, 2.0 and so on? If the previous example what we do is, you will substitute. For example, you have F1, right? F naught. So what we do is, we substitute 1 into this equation, right? And then we get the value. But for this question, they have no equation given. Dia tak ada bagi pun soalan. Dia tak ada bagi pun equation of fx. But it give you table of data, which mean this question is more easier for you. Maksudnya dia tak perlu you calculate lagi. It's already calculated for you and it's already given in the table. Can you see? Can you see the difference between this example and the previous one? The previous example give you function and then you need to calculate it by yourself. But for this example, it's already calculated and it just it's already calculated and it gives you table. So means that you just using that data. You just take that data and then substitute here. For example, here f2.2, right? So you can see that when x 2.2, this one, right? This one x 2.2. So this is x, this is f. So x is 2.2. Okay, x is inside there. So what is the f2.2? F2.2 is this one. So 19.8550 minus now 2.0. This is 2.0. So f2.0 is 14.7781 over 0.2. Okay, so now solve lah. Okay, so the answer you should get 25.3845. Okay, alright. Okay, so I think I just stop it until here. So you can try by yourself to get backward and centered. Okay, so by using this table, tak perlu dah calculate, tak perlu dah. So you just take it all this value. So I give you the answer for what we call, okay, for backward tadi. Okay, I do it for forward. So the answer for backward, okay, you can try by yourself. The answer for backward is 19.4435, and the answer for centered 22.4140. Okay, you can try by yourself. Okay, and then yeah, like I said, for the second derivative also is the same, just a different formula, and the formula for high accuracy also is quite low lah compared to the normal accuracy. Okay, so you can try. Okay, you can answer example on the slide, exercise on the slide. Okay, alright, so means that we already finished the numerical differentiation. So yeah, for me this topic is simple. It's just what we call, it's just use the formula, and the formula pun tak perlu nak hafal. Okay, tak perlu nak hafal. Make sure you just take it from the, tak kisahlah you nak tulis macam mana pun. Macam if you want to use my table yang I bagi, you fill up that one. So yeah, you can bring that one along. Maksudnya dalam test pun, dalam final pun, sebab we open book, right? And also it also give you in appendix, if I'm not mistaken lah, dia akan bagi dalam bentuk appendix. You boleh refer to that one. Okay, so yeah, that's all. So I will see you next week. Okay, next week we will enter the new chapter, which is integration.